Alright everyone, so I'm going to go over this sheet that we're working on not too long ago in class. I'm going to do problems 1, 2, and 3, which will be important for your assessment, but also I'm going to have you give you a little bit of time to do 4, 5, and 6 for actual practice. Okay, so we did number 1 in class, and to row, put it on the board. So Miss Lockheed jogs 8 times around a 400 meter long track in 12.5 minutes. So let's determine the average speed of Miss Lockheed. So part A, we know that the distance equals 400 meters. But remember, she did it 8 times around, so that means she traveled that track 8 times around. So that actually equals 3,200 meters. Okay? It took her 12.5 minutes. And then we're asked the average speed. So speed is linear. So then we know our equation is this equals distance, so total distance over time, and that is simply by plugging in 13 meters with 12.5 seconds, or sorry, minutes, equals 256 meters per minute. Okay? If I need you to calculate the answer in meters per second, I will make sure to let you know that in the test that I'm giving in question number also. Okay, part B, a little different, right? So since Miss Lockheed is going in a circle, if we're asked to find the average velocity, instead of it being the total distance, as would be an average speed, you're looking for the displacement or a change in position. So she actually, if she's going in a circular track, her start and end is the same place. So overall, did her position change from the start to the end? No. So it's 0 meters. Okay, that is because the starting and ending point are the same. So there is no change in position, or change in x, or we can also say displacement. Really Alright, number 2. So a Labrador Retriever runs 50 meters in 7.2 seconds to retrieve a The dog then runs halfway back up in 3.85 seconds. Remember, it's halfway, okay? Determine the average speed and velocity of the dog. Draw a motion map to help. Okay, so let's start with doing that motion map. This is going to help us solve our problem in a couple ways. Okay, so let's remember 10, 20, 30, 40, 50. So now we ran 40 meters total, starting at 0 here. Alright. So if that dog ran 50 meters in 7.2 seconds, then we need to make sure that we're representing that also with our motion map. Okay? So we need to represent it right here. 50 meters in 7.2 seconds. So this is just going to be a rough estimation, unless you want to do calculations, which essentially is what we're going to be getting to. So the dog has to run a little bit faster, or a little bit under, rather. 10 meters a second is 7.2 seconds. Okay? So we will represent approximately 7 meters. No, it's not my best. But it's just a sketch of that. And then it goes back in 3.85 seconds, halfway. So we have to at least get it to 25 around here. So 1, 2. Okay, so the general gist of it. Now, let's figure out how to get the speed first. So what do we know? What's the total distance that dog traveled from front to back? Well, that is 15 meters plus the way they went back. And half that way is 25. Equals 75 meters. And then the time would be however long it took to go this way, however long it took to go this way. So that total would be 11.05 seconds. And we're looking for our speed. Okay? So plugging that in, the S equals d over t. And then just plug right in 75 meters over 11.05 seconds. Use your calculator. You get 6.790. Let me know if that's a miscalculation. You guys can see it. Now, if we're going to be doing the change in velocity, or the average velocity of that dog, we'll need to do the change in x, that change in position of that dog. Instead, let's try that out. And that would be, notice, the dog went 50 meters, and then went back 25 meters. Okay, so we're actually having to take into account direction now. Remember, velocity takes into account direction, like the difference between speed equals 25 meters. Alright, time would be the same, so take the same amount of time, 11.05 seconds, and we're looking for velocity. So same gist, equals change in x over t, is our velocity equation. That we just plug in 25 meters over 11.05 seconds equals a positive 2.26 meters per second. Okay, that's our velocity, so that's how fast we work per second. And the speed was how long it took us to travel the entire distance, entire path, not caring about direction. Okay? Lastly, let's look at number 3 again, which we again did in class. This is the comparison between the device. A ball going downhill, a fish going upstream. So always label. So ball, how long does it say the ball was traveling? T equals 6 seconds. And it said it rolled down the hill in 3.4 meters. Or by 3.4 meters, and we're looking for velocity. If we just plug in our equation, just like that, we will get 0.57 meters per second. Okay? Really just following these steps, hopefully this is getting a little bit intuitive for you. Versus the fish. Okay? Again, labeling out everything. So the fish change in x will get traveled 5.4 meters, and traveled 0.4 minutes. So this is the catch. We have to make sure that we're converting those minutes to seconds, okay? So to do that, we create some kind of conversion factor. So if we know we're trying to get rid of the minutes, we want to put the minutes in the denominator so that they cancel out. So how many seconds are in a minute? Well, 60 seconds are in a minute. So that would give us the equivalent there, and that equals 24 seconds. Remember, it's 0.4, not 4. Okay. Then we're solving for velocity again. Solving it, v equals change in x over t equals 5.4 meters over 0.4 seconds. It was 0.23 meters per second. Which one is faster between 0.57 and 0.23? Well, it's definitely the ball that is faster. Now I want you to try 4, 5, and 6 on your own. They get a little bit more difficult, but really is asking the same things. So just make sure you're thinking about the problems and you're writing down what is given to you and what you're looking for, okay? Refer back to your notes for the difference between average speed and average velocity. If ever do get unclear, always